All right, started. Okay, so there's gonna be a little funky discontinuity because I realized that I should have. I was looking at the pre-lab itself, and the first thing it says is to read through the verse for background. So you've got your objectives. So yeah, this is one lab that I've worked on a lot because the original was so bad. Okay. Go to the module, read the latest version, and take notes. And so go here. A little bit of a blurb about the background. I summarized it for you. So this is a very useful picture here. And talk about how the electrons are accelerated and the how they're created, how they're accelerated. We'll talk about these they have a name for it in this sim here. I never heard that name before, but what this does is it creates the beam. They see these positive voltages, they start screaming towards them, and then these openings, they're called collimators, and they help create a beam, and I'll talk about that in class. Then there's the Helmholtz coils, and then this business of in the field is all done in the sim. And so the experimental procedure is that we're going to first of all determine the sign of the electrons, because we have the Lorentz force and an equation. I'll show you that in class. Second part is we're going to determine, we're going to make a table of a series of voltages, and we're going to measure the radius while keeping the current constant. And then we're going to keep the voltage constant and measure R for a series of I's current. So the actual lab time is pretty darn straightforward. And then analysis part is already in the playlist. Right, so there's the sim, and then this is gonna be like a skip, and I'll be talking about this guy here. And right, I have to change this to say laboratory. And I would encourage you, actually, laboratory. I would encourage you guys to practice what's actually in the lab write-up in the manual, because what you do in the pre-lab is slightly different, where we're going to come up with an equation for R, and we're going to adjust the current and the voltage both at the same time, actually, and then we're going to see what the resulting R is. You're going to predict the R and see what the R is. In the case of that is presuming you know certain things, whereas when we're in lab class, we're going to do this in the same manner as if we were doing the experiment the first time. And so we're going to produce those two tables, and then we're going to do a fit. And if you recall, we did this in class in week 1, because this lab has, it's very pre-lab and analysis intensive, and a lot of you have never done it before. So that's why I decided in week 1 to do a practice run. Okay, very good. Have fun. Okay, talking to myself. Okay, I wanted to go over. Oh, it's not even here. Let's see. The pre-lab. Let's see. Yeah, go here. Oops. Yep. Okay, pre-lab assignment. And you'll see this document. And so we have some objectives. I guess I should update this because I'll double check. I forgot to read over the manual. I was focusing on step 2 onward when I was editing this yesterday. Okay, so what's going to happen is you're going to open up this sim here. Let's see if it works from here. Let me just check something. I click it here. Okay. Well, it's 2 things. I held down the control key and it worked. Oh. Plus, on top of that, there's a link in the module to, yeah, here it is. And there's some, I guess I made a recording about how to use it, but this is what this is, so this is okay. Okay, so there's a series of tabs here, I suppose. I forget, these is a menu bar, menu items. Show derivation. Oh, right, this is, got it. So, basically, the derivation's not important. But what is important that you describe what Helmholtz coils are. And this number here, I think, is a little bit different for us. It has to do with the particular coils you're using. Okay. What is A? The Tesla. Oh. Amps, but then what's I? Coil current is I. Why don't we look at the derivation? And it doesn't tell us. Okay. But that's units anyway. Oh, here we go. And it still doesn't tell us what. Yeah, it has to be area. Because I know, well, that's permeability. That's not magnetic moment. That is weird. So anyways, read up, make notes about that. Then there's the setup. We have a little bit different setup that we have a base, and it has the power supply for the gun and the power supply for the coils in one unit, and we just have 2 knobs to twist. So it's been dumbed down, but at the end of the day, I'm surprised there's. Oh, I know why. Because they give you control. There's a glowing filament, and and that's why you would need to look at the manual. Okay, I'll loop back to that, and then now you get to play with things. And see what goes on. And now it shows all the various parts. Notice you change the magnetic field. And things happen. And that's what here's the task. Take some notes. And then there's a quiz. And let's go back to the... So go through 1, 3, take notes, right? Make sketches. 4 and 5, that's what we're on right now. So it's testing you to see if you're understanding things. And then now it's another bit of a quiz. Okay. Whoops. And yeah, analysis. Let's see. Write down the 2. Check hypothesis analysis. Okay, so it's not exactly an analysis. What it is the it goes over the final derivations. This is up till this point you were told that you have an accelerating voltage, and then you have a current that controls the B field, and now we have this so-called Lorentz force, and we equate that to the centripetal force from Physics 2100. You see F centripetal. This is a German site, and this is super important. This equation here, and here you can actually check the validity of this equation that was derived. And we go back to the actual assignment. And so let's see. Yep, we need notes about that. Then what you do is you go to the manual. I'll pause this for a moment. So equation 3 is the equation that lets you get velocity as a function of voltage. And then let me go back to the assignment. Go to the lab manual, find the two expressions that give the B field as a function of I. And there it is. It could be that it's the same. 7.7. Let's go take a look. Because my recollection is that, yeah, it's slightly different because these coils are a different size. Radius and the Helmholtz coil used here. Yep. Okay. All right. So we have a B field. I see you have velocity squared there. Okay, slow down. Let me go through this one more time. I'm going to pause. Okay, so step 6 says go to manual, get the expression for the B field as a function of I, and the speed V is a function of voltage. And so I've got the two equations, and I realized that this one is for us, but we need the one for the particular setup. So that means we go back here, and that's the one we want. Good thing I made the video. Okay, and then so this is for our setup, but this is the one we need for the sim. Okay, so you see now we can break this down into two parts. R equals mv over E, and then 1 over B. And so the B part's pretty straightforward. And then you see here, you can manipulate this, and you can solve this for V equals something over something, and there's a capital V here. It looks like there's a square, at least something like that. Oh no, excuse me. Yeah, because you got to take the square root, and then you plug it into here, and then you'll have an expression for R that's proportional to V and I. And then you can, so then in the pre-lab, I gave you some numbers, a voltage and a current, and you can find out, you can calculate the R. And then you can go to, in fact, not the the laboratory tab. I'll have to fix that. And you can plug in, you see a voltage and a current, and then you can check and see if you got the right answer, because this thing it'll tell you right here what the answer is. Okay. All right. Let's pause this for a moment. And then the final part is that, let's see, from right to left. So that means, I think I brought, yeah. So from right to left, guys, means from right to left. And it has some velocity. And you know it's an electron, so you can look up its charge. You have the field strength. The direction is into the page. And then you can calculate, you can sketch the shape and whether it's going to be clockwise or counterclockwise. And you can calculate the, you got to look up the mass of the electron, and you can calculate the radius. Okay, let's pause again because I wanted to loop back. Actually, I know what I'm going to do. I'm going to stop this. I'm going to make a new recording and just splice it into the front.